Will explain to you how to calculate the solubility S from a given KSP solubility product. So let's say you have a question to calculate the solubility of silver carbonate given that the KSP of silver carbonate is 8.1 times 10 to the power negative 12. Note that in these questions the KSP will be given in the question. So step 1 is to write the equilibrium, the solubility, the ionization equation of silver carbonate. So Ag2CO3 solid, which is insoluble, but when it ionizes, it will barely give me silver ions and carbonate ions. So we need to balance this equation. I have 2 silver ions. So step 1 is to write the equation. Step 2 is to place under it, to substitute, to write how this is going to dissociate the solubility. So it's going to get me 2S, 2 solubilities for Ag plus and 1S for carbonate ion. Now step 3 is to write the formula, the equation, the expression of KSP products. And the expression of KSP product, I also mentioned it in previous tutorial videos that you can find on my channel. It is the concentration of the ions raised to the power of their stoichiometric coefficients. So Ag squared multiplied by carbonate to the power of 1. Now, step 4 is to substitute this formula of KSP with the S values. So this would be 2S squared multiplied by S. So finally, the expression of KSP in form of solubility is 4S cubed. So therefore, to calculate the solubility, we will say that S is equal to KSP divided by 4 cubic root. Now, the question could be to calculate the solubility in gram per mole or to calculate the solubility, the molar solubility in mole per liter. So from this expression, we can directly get the molar solubility, which is in mole per liter. So I'm going to substitute the value of KSP, which is 8.1 times 10 to the power negative 12. I'll divide it by 4 and I'll do cubic root of this value. So it's going to be 8.1 times 10 to the power negative 12 divided by 4 cubic root. The answer is 1.2 times 6 times 10 to the power negative 4 mole per liter. Now, if this question is asking you to calculate the solubility in gram per liter, therefore this calculated molar solubility, you will have to multiply it by the molar mass. So to get the solubility in gram per liter, all I need to do is multiply this given value by the molar mass of silver carbonate, which is equal to 200. The molar mass of silver carbonate is equal to 275.75. I'm going to explain this now. This is in mole per liter, and the molar mass is in gram per mole. So if I multiply them, the solubility will be obtained in gram per liter. Let's take one more example of calculating solubilities. So ZnOH2, as I mentioned, step 1 is to write the ionization equation. Step 2, this is solid. Step 2 is to write the expression of KSP, which is zinc multiplied by OH minus squared. And you substitute the values, the S. So this is S and this is 2S. So this is going to be S and 2s squared. So it's going to be 4s cubed. KSP is 4s cubed. Now, of course, in this question, they will give you the KSP of zinc hydroxide, which is equal to 4 times 10 to the power negative 12. So, if I want to calculate S, I will do cubic root of this KSP divided by 4, which is the cubic root of 4 times 10 to the power negative 12 divided by 4. And finally, the answer is, so cubic root to this answer is 1.0 times 10 to the power negative 4 mole per liter. As I mentioned in my previous example, this is a molar solubility. So if you want to calculate it in gram per liter, all you need to do is multiply this molar solubility by the molar mass of zinc hydroxide, which is 99.42 gram per mole. So here's the molar solubility. If I do this, I'm going to get an answer in gram per liter. Now, what if in this question they asked you to calculate, after finding the molar solubility, they asked you to calculate the concentration of OH minus or the concentration of zinc 2 plus. So the concentration of OH minus, as designated here, is 2 times S, and that for zinc is just the solubility. So all you need to do is the calculated solubility, you just have to multiply it by 2. So this one multiplied by 2. And for the zinc, the concentration of zinc is simply equal to the molar solubility of this compound, mole per liter. And this one is going to be 2.0 times 10 to the power negative 4 mole per liter. Now, sometimes they might go further in the question, and since you have here OH minus, they might ask you to calculate the pH of this salt, of this insoluble salt. So in this case, this is a calculated OH minus. pOH is given to be known as minus log OH minus. So I calculate pOH minus log of 2.0 times 10 to the power negative 4. And from the pOH, I can calculate again the pH. So the pOH is going to be 3.69. And therefore, the pH is 14 minus the pOH. So it's 14 minus 3.69. And the answer is 10.3.